All right, first assignment of the winter term. We're going to do this a little out of order. We're going to do chapter 9 in class for the next 3 weeks, and then we're going to go have you guys do chapter 8 on your own over the break. So, currently in the middle of rearranging the haiku page, but for now it's going to look kind of like, it's ultimately going to look like this. We're going to have winter and fall, so if you go to winter, right now there's not much there, but there will be. So week 1 through 3 of the winter term, so from the 3rd of December through the 18th, and what you're going to need to do there. So I'll fill in all the chapter 9 stuff that's going to go there. But if we were to go look at this 3-week syllabus, you'd see what's going on. Also, the calendar is updated for the first 3 weeks. So on Wednesday, you're going to have a RQ, so reading quiz 9193. We're going to do assignment 91 in class. Thursday, assignments 92, 93, and then our 9.1 is due, uploaded via haiku, etc. 2 reading responses on the 9th and the 16th. And then, haven't filled it in yet, but we'll get it up there. So the 18th would be our chapter 9 test. So actually, why don't I just go ahead and put that in there. So if you are planning on leaving early, you need to talk to me so we can figure that out. So chapter 9 test. And then chapter 8 you'll do over the break. There will be some stuff up on haiku. There's going to be some worksheets to do, as well as a take-home test that need to be turned in the first day back. So that's sort of the prospective schedule. It's going to fill out a little bit more as we get stuff done. But that's that. So chapter 9. I'm going to start off with, this is interfaces and polymorphism. These are kind of some bizarre concepts, but hopefully we can explain them. So page 388, 9.1, using interfaces for code reuse. So use interface types to make code more reusable. So for instance, if you look at the data set that we've been working with, currently what it does is it will get the maximum of a set of, however you want to set them up, a data set in an array or whatever. It'll give you the maximum value of bank accounts. And then we could do the whole same thing for coins. We could add a coin to my bank account or to my data set class. And notice that the implementation is essentially the same. So for the bank account, if I'm going to add, really? My board doesn't work? I should have tried that first. So if I want to write void add for a bank account, I'm going to pass it a bank account type, and then I'm going to check if my current maximum bank account is greater than or less than, or is greater than the one I'm looking at. If it is, I reset, and we go from there. Nothing. All right, well, we'll do this the old-fashioned way. So currently, we have public void add and the type. So in this case, it's going to be bank account X as my parameter. And then I bring it in, sum equals sum plus X dot get balance. Remember, since it's an object, I got to use the methods. I can't just grab the instance field. And then if count equals 0 or maximum dot get balance, the current maximum bank account object is less than my temporary one, X dot get balance. I reset. Alright, so reset maximum now equals X. Just reset the reference to the address. So I can do averages, we'll increment count, right? And then get maximum will just return it. So that's how it would work if I'm going to do a bank account. If I want to do a coin, well, I got to have a coin type. But essentially, there should be an equal sign up here. but I have to use the methods for the coin class. They're a little different, but this part's going to be the same. Sum plus x dot, but I can't use get balance because get balance wasn't a coin thing. I have to use get value. That's the coin method that returns the value of my coin. And then if count equals 0, that is I haven't actually done anything yet, or maximum dot get, now I'm checking coins, so get value is less than my temporary one, reset. Ooh. Stupid tiny keyboard. Alright, so I could do this. Now, notice that they are, with the exception of the parameter type and the name of the method, they are identical. So there's, the idea behind an interface is I can shorten this up to be one generic comparison, and I'm just going to change my parameters from specific classes to a more generic, sort of hide it as a generic class. So that's what an interface is going to be. An interface type declares a set of methods and their signatures, but it doesn't give you any implementation. So since the fundamental mechanics of analyzing the data is the same in all cases, but the details of the measurements differ, I can go ahead and make all of these classes agree on a single method called, well, let's just call it getMeasure, that obtains the measure to be used in the data analysis. For bank accounts, getMeasure returns a balance. For coins, it would return the coin value. And we could then shorten this up and just, instead of writing a new method for every class, I can write one method and have each class sort of give me this, implement this generic one. So I could have sum equals sum plus x dot get measure, okay, and then if count equals 0 or maximum dot get measure is less than my current one, reset. Alright, so that's all the same. Nothing has changed there. That would be my same one, my same condition. And then the trick is to remember what's the type of variable x. Well, x should refer to any class that has this getMeasure method, so obviously it can use it. So in Java, an interface type is used to specify required operations, and they're going to do sort of specify this generic concept for us. So we're going to have what's called an interface. We're going to write it as public interface. You're going to give it a name, but it's not a class. You're never going to make objects of it. We're going to call it measurable. Now it's going to define the methods that anything that wants to use this sort of generic getMeasure should do. It's just going to have an empty method in it, method header, or it could have more than one, but measurable only has one, double getMeasure. Now anything that uses the interface measurable has to have a getMeasure method that has to do something in it. Okay? Remember, measurable is not a type, okay? It's just, this is, one we made, and unlike a class, an interface provides no implementation. So if you look on page 390, an interface type is similar to a class, but there are several important differences. All methods in an interface type are abstract, that is, they have a name, parameters, and a return type, but they don't have an implementation. All methods in an interface type are automatically public. You don't have to write public right here. That's already built in. Okay. And interface type does not have any instance fields. Alright, so now I can use the interface type to declare the variables x and maximum. Okay, so now my dataset class is going to change slightly, and it's going to be public void add my generic interface. Okay, not a specific class. And then I'm going to do the same, sum equals sum plus x dot get. Now I have to get the generic getMeasure, and it's going to go find the actual class and figure out how to do this. And then if blah 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 blah, all of that. Okay. And then public measurable get maximum, in which case I just return my maximum And then I have my instance fields I need to reset. Private double sum, private measurable maximum, and private int count. Okay. Use the implements keyword to indicate that a class implements a interface type. So class implements measurable. So what we would have to go then do is modify the bank account. Okay, and as soon as we say implements measurable, we're going to have to override the get measure somewhere in there. We know it's double because it said so. Now here's where we get to specify all these unique types, how they work. Because up here we have get measure, which is just the name, but in here would be in the dataset class. Here's how I tell it what to do with get measure, but it doesn't actually tell me how to get any sort of values from the object, because measurables don't really exist. So in each class that implements this interface, I have to tell it, all right, how to get the number that I'm going to be measuring. Now in a bank account, it's just the balance field. Okay. For a coin, it is the value. So specific to each class, you write how to get some double number relative to that class that you can then compare to get maximum and add a sum and get an average. Okay, and the term for this is to reduce coupling between classes. That is to sort of reduce how much work has to get done. All right, so 9.1, using codes for reuse. If you look at the dataset tester on page 393, it goes ahead and makes a bunch of bank accounts and a bunch of data sets. What it doesn't show you is the data set, the modified dataset class with the interface. All right, that's going to be on page, in section 9.4 on page 401. All right, so we're going to go to 9.2 and then keep going. So converting between class and interface types. Interfaces are used to express commonality between classes. So in this section we discuss when it's legal to convert. So if you look at the call, we'll give ourselves a little space here. So if you look at bank data, if that was my data set, add, okay. Now, I'm going to make an abstract class, new bank account, initial balance at $10,000, okay. And I'm going to throw it into this. Now, bank data, the add method, is actually up here looking for a measurable type. But I just threw it a bank account. But that's okay, because bank accounts implement measurables, so the computer will go and sort of wrap it up and hide it. So you can convert from a class type to an interface type, provided the class implements the interface. Okay. And this is this line here is sort of shorthand for something like bank account equals new bank account with 10,000, and then measurable x equals account bank data add x. Sort of this line is all three of these sort of put together. Now, occasionally, okay, so let me get ahead of myself. So a measurable, you don't actually know the exact type of the object to which x refers. All you know is the object has a get measure method. But you can't convert to unrelated types. I couldn't put measurable x equals new rectangle because rectangle doesn't implement the measurable class. Now, sometimes I want to go back from my measurable, my interface type, and I need to convert it back from an interface reference to the object in which it was. The dataset stores the object with the largest measure, stores it as a measurable reference. Now, if I was dealing with coins, then I would take measurable max equals coin data.get maximum. And what can I do with the max reference? You know it refers to a coin, but the compiler does it. So you can't call get name on measurable max because measurables don't have a get name. They all they have is a get measure. So you have to cast it back, okay, to go from the interface to the class, excuse me. But you can only do that as long as you are absolutely sure that max is, in this case, a coin. If it was a bank account, you're going to have problems again. Okay, you're going to throw an exception and terminate. There's one big difference between casting number types and casting class types. When casting number types, you can lose information, and you use the cast to tell the compiler that you agree to that information loss. When casting object types, on the other hand, you take a risk of causing an exception, and you tell the compiler that you agree to take that risk. Okay. So 9.3, polymorphism. All right. So when multiple classes implement the same interface, each class implements the methods of the interface in different ways. How is the correct method executed when the interface method is invoked? So when I call x.getMeasure, but how does the compiler and the computer know that x is a bank account? Or next time x might be, and it has to go get the, they call the get balance to go ahead and get the balance instance field. Or it could be, x.getMeasure. In this case, x could be a coin, in which case it needs to go get the getValue method from getMeasure to get a hold of the value instance field of the coin class. So how does it know how to do that? So I have variable types who have our interface, which is fine. I could do something like I can have an instance field or a variable of an interface type. That's perfectly legal. Measurable x. Okay. X doesn't have a type measurable. In fact, no object is type measurable. Instead, the type of the object is some class that implements the interface. So note that x can refer to objects of different types during its lifetime. So I could, once I have measurable x, I could say x equals new bank account, which is perfectly fine because bank accounts implement it. And then I could even later on say x equals new coin, with the proper parameters. Those are both fine because they both implement the measurable interface. The Java virtual machine makes a special effort to locate the correct method that belongs to the class of the actual object. That is, if x refers to a bank account, then the bankaccount.getMeasure method is called. If x refers to a coin object, then the coin.getMeasure method is called. Polymorphism denotes the principle that behavior can vary depending on the actual type. So polymorphism meaning many shapes. So you see a polymorphic method called such as x.getMeasure. There are several possible measure methods that can be called. Okay. This is kind of similar to overloading, with one main difference. Okay. The compiler picks an overloaded method when translating the program before it ever runs. That's just called early binding. All right. When selecting an appropriate getMeasure call in x.getMeasure, the compiler does not make a decision when translating. The program has to run before it can know what is stored in x. That is late binding. So those are two terms that you would need to know. So that's the end of 9.1 through 9.3, over which you will have a reading quiz. But we will go and look at the implementation of the measurable interface. So if I look at this diagram, there's my main class, my dataset tester, which creates objects of the dataset class. Now the dataset class uses the measurable interface. All right, coins and bank accounts sort of use or hide themselves as measurables so that the dataset can use them without having to keep writing new implementation. So if I were to go into coin, notice now it says coin implements measurable. And since it implements measurable, I have to override the getMeasure method and tell it how to get this back. So in this case, I return the instance field of value. Now, bank account also implements measurable, which means it has to have somewhere in here a getMeasure, and the one that I want to override is, or the one that I want to return is the balance field. Those both go through the interface, which has no implementation, just a way of computing the measure of an object. Dataset class has now been modified that add refers to a generic interface type measurable x using the getMeasure method, and everything else stays the same, except it doesn't have a clue which type it's working with. And then dataset tester runs the whole shebang. So I make a new dataset called bank data. I add 3 bank accounts to it. All right. Now these are anonymous classes with no object, or anonymous objects with no name, and we're just throwing them into our bank data. And then we're going to print the average. We're going to get the average. We're going to print what we expect it to be, in this case 4,000. I'm going to make a measurable type of bank data.get the maximum, which returns a measurable. And then I have to call the get measure value to print the highest balance. Now, since I don't need to do anything but use get measure, I'm not trying to get any other, I'm not depositing or doing anything like that, there is no requirement to cast measurable back to a bank account type, because all I want is the double value, which get maximum is more than capable of handling. Then I'm going to make a data set of coins and do the same thing. So if I were to run this, and in fact it does seem to work. So that is using interfaces for callbacks.